Okay, wow. Hello world. Okay, my name is Liukas. I'm going to share actually the story of this picture, so I'm not going to go any further in detail into that. My presentation title is Inga, kartor, bara, kompasser, and I'm not sure if I totally butchered that away. I'm a children's illustrator, a very mediocre programmer, and a business school dropout. And I come from Helsinki, Finland. And since there's a lot of Scandinavians in the room, you know how self-deprecating we tend to be, how much of an imposter syndrome we have. So the only identity that I feel very certain about sharing on stage today is that I'm a business school dropout. I co-founded an organization called Rail Skills that teaches young women programming skills, gives their first experience in software craftsmanship all over the world. And I worked in New York City for 1.5 years for this company called Codecademy that teaches teaches all ages of people programming skills. And I had all of this zeal to change the world. I come from the startup scene of Helsinki, Finland, and I was like, go west, young girl, and change the world and do amazing things. And I joined Codecademy when they were 5 people, and we were less than 1 million users, and both of my bosses were 22-year-old boys. And I left 1.5 years later when we were 24 million people, and 24 million users, and 30-ish people, and my bosses were 24-year-olds. And I had all of this startup passion and energy to change the world, but I had started to question the fact that is it really so that the biggest change in life happens through technology companies, through companies that create apps for ordering pizza or beer to the office. And I came back to Helsinki and had a lot of time to wonder what to do next. And I figured that maybe the biggest change actually happens when you're 6 years old. Maybe if we can change the way a child sees the world, we can drive for the biggest, the most scalable change in the world. And that's when I decided that I'm going to be a children's book author. And to get to this whole story, I think we need to go a bit more back in the time. And this story, like all the great stories in the world, it starts really from love. Yeah, love. This particular love was a love I had when I was 13 years old. I had this mad, burning crush to an older man. And the older man in question was the Vice President of the United States, Al Gore. And everyone else in my classroom, they would love Legolas, and they would love Elijah Wood, and they would love Ville Valo, who was this goth like rock star in Helsinki. But I would love Al Gore, and I would have this scrapbook with him, about him that I would carry everywhere. And soon the pictures were not enough. I needed to do something bigger and more impressive. And I decided that I'm going to program the first and probably also the last Finnish fan site for Al Gore, and here it is. And this was 2001, which meant that there was no Tumblr, there was no Facebook, there was no Twitter, and in order to express all of this love and this lust and everything, I needed to learn to code. So I learned PHP and HTML and CSS and how to set up my servers, and boy, when this website was ready and up and running, I was like, wow, this is what I want to do in life, this is who I am, this is amazing. But there were other boys. And there were other things to get excited about as a 13-year-old, like social sciences and history and art and business. And slowly I started to feel like the world of technology, it felt introverted and lonely and mathematical, and it belonged to the nerdy boys in the class. And I wanted to be on the other side of the world, the colorful side of the world where change happens. And I forgot all about coding and technology for the next 10 years. And it wasn't until I was studying in Stanford University in 2009 when I stumbled upon this quote by Steve Jobs, who says that learning to code teaches you how to think. Computer science is a liberal art. And I happened to stumble on this Ruby on Rails for beginners programming class and wrote my first lines of Ruby, and I was absolutely, totally hooked. And I realized it had nothing to do with Al Gore, it had nothing to do with the teenage hormones, it was the coding that I was so bonkers about. And I was hooked, and I wanted to get other people hooked as well. So me and my friend Karri, we co-founded an organization called Rail Skills in Helsinki. And this was supposed to be just a thing that we would do, like 25 of our close friends would come to the office of Karri's then employee, and we would just build something really quickly and give them their first experience of what it is like to write coding. But then the internet happened, and people started to tweet about the whole thing. And that guy over there, he's DHH, he's the founder of Ruby on Rails, and he has like a very foul mouth and a gorgeous hair. And he tweeted that, oh, like cool things are happening in Helsinki. And I remember thinking that this is the highlight of my life. And I printed out the tweet and put it on the wall. I'm like, whoa, nothing is ever going to happen to me that is going to be equally exciting. But cool things happened, and today Railscars has been on over 250 cities all over the world, from Amman to Australia, from Belo Horizonte to Berlin, run by local volunteers, young men who want to see a more diverse world of technology. And the reason I'm talking to you about this is because we're going through such a fundamental change in how companies operate in this world. And this is the title of the talk, really. No one has a map to the future. We only have a compass. We only know the direction. And the direction is this. Every single company is going to be a software company. That's a pretty bold statement, but think of it in these terms. Every single company used to need to think like a bank because money was the thing that was a restriction in the world. Nowadays, people and talent is the restriction we have. And more companies like Amazon and Google and Apple and Spotify are changing our world at a rapidly changing pace. And one by one, the physical artifacts of our world are disappearing. We don't have wallets anymore. We have mobile payments. We don't have CDs. We have Spotify, and so on and so on. And it's not only here in the Western world. This is a study from World Bank says that in 2020, 80% of adults will have a smartphone in their pockets, which means that here, US, but also in India and Africa, and all of a sudden it's a really relevant question to ask, what can Swedish people do for the African mobile market? What kind of products and offerings we can have for them? And it's not anymore about humanitarian efforts or so forth, it's business. And it profoundly also changes the way we build companies. It means that when WhatsApp was sold for $19 billion for Facebook, they only had 30 engineers. And when you guys had Minecraft being sold, they had 40 employees. And here in Finland, we had Supercell, like half of Supercell was bought by SoftBank, and they had 90 employees at the time. And then we have the lackluster story of Nokia and the thousands of people they employed. It means that smaller and smaller companies can do bigger and bigger things faster and faster. But the thing is, I'm not an economist, I'm a children's book writer, I'm a storyteller, and I'm not here to talk to you about the software eating the world. The premise where I started my work from was that if the first foreign language for our kids will be English, Chinese, and JavaScript, we should be teaching them poetry, not grammar classes. And what I mean with that is that when we learn Finnish, we don't only learn to conjugate the weird verbs or learn about the perfect and imperfect and future tenses. We learn to write poetry, we learn to write columns, we read contemporary authors, we read classics, and we learn to use the language. And in the same way, we should be learning to use programming languages. So here's where I started from. This was my premise, and I wanted to be a children's book author. This was roughly 2-3 years ago. I ran into a few little problems on the journey. First of all, I had never written a book before. Second, I wasn't an illustrator. And third of all, I still didn't consider myself to be a very good programmer. I was pretty mediocre. I didn't have a PhD in cognitive sciences or computer science or pedagogy. And I think it's computer science that taught me resilience, taught me to figure out problems one by one, and I figured that, okay, let's take drawing for instance. Drawing is mechanical repetition. Some of us are born as great artists, most of us are not, and if I draw 1,000 circles, eventually the circles are gonna get better. And this was my quest for my 1,000 circles. These were the first pictures that I could find, maybe from 4 years ago. You can see they are not very good, but I kept drawing, and the little girl character started to appear. I was teaching myself programming at the time, every time I would run into a hard word like object-oriented programming or garbage collection, I would try to figure out how would a 6-year-old little girl explain this word. And I would start to all of a sudden see the world of technology as stories. And you know the way some mathematical people see numbers as colors, I would see the world of technology as stories. And I'm going to tell you a few examples of those stories in a second. It also really helped that I had this global community of passionate people behind me who started to send me pictures back, like, hey, here's Taipei, and this is how we would think a 6-year-old little girl would see the world of technology. And here's Ukraine, and here's a bunch of cities that I can't even pronounce at this point. And I also got plush toys from Belo Horizonte, and I was starting to get a feeling that, hey, maybe there is a demand for this. Maybe there will be people who are excited about this stuff. And the story started to get better. So I spoke about the idea of seeing the world of technology as very humane, as full of stories, so which like naturally led me to think that, there is this big company that starts with a G, and when I think about them, they really seem to be super friendly, but absolutely horribly messy, and maybe they should be represented by this green robot. And then there's this other company that likes things clean and neat, and doesn't want to play with the other kids. That's Apple for sure, and the snow leopard. And then there's Linux the penguin, who's impossibly clever and fast and consistent, but super hard to understand at times, and Firefox, the idealistic fox, and so forth and so forth. And in January 2013, I felt that, okay, now I'm ready to put this thing online. And I did the one thing that I feel like still is probably the best and the worst decision I've ever done. I decided to put this project on Kickstarter and asked for $10,000 to self-publish. And in 30 days, the project raised over $380,000 worth of pre-orders on Kickstarter, everywhere again, all around the world. And this actually is still one of the most backed projects, children's publishing projects on Kickstarter. And it also represented 20% of the annual Finnish book exports of the year. And I had no freaking book in my hand. I was panicking and laughing at the same time and trying to figure out what to do next. Much of last 1.5 years, I felt like Alice in Wonderland. I took the red pill, and I felt deep, deep inside of the computer, and I've been trying to figure my way out of the computer. And I don't know, if there's one thing that I've learned so far, it's pretty much this second quote that I'm going to show you. So the idea was to do a storybook and a workbook that teaches you the foundations and fundamentals of computational thinking. And this is the sketch that I put up on Kickstarter. I had a nice little video and some sketches, and you can kind of see stuff there like bug Sudoku and my first error message and find the differences and connect the shapes. But those of you who are now in the audience and feel like, what does this have to do with programming, I ask you, young lady, you're absolutely right. I'm ashamed that this still exists out there. This was the first draft, the first idea. But what I've learned in the past 1.5 years is that you don't go from here to here, where you actually have 130 pages of a book and you have tested and assessed curriculum and workbooks, unless you have the grit and the courage to put the horrible, horrible first version out there. And there's one quote that really kept me going when I was really doubting myself and my own abilities, and it's this. I'm not going to read the whole of it. It's from Ira Glass, the podcaster and producer of This American Life, and he says that nobody tells this to people who are beginners. I wish someone told me. All of us who do creative work, we get into it because we have good taste. But there is this gap. For the first couple of years, you make stuff, it's just not that good. It's trying to be good, it has potential, but it's just not that good. And I'm trying to remind you all that everyone goes through this gap. No one is born ready in doing what they end up doing in life. And it's about the grit and resilience to go from here to here and never let go. So, back to the world of programming. So if JavaScript is the lingua franca, more poetry classes, less grammar classes, and the whole perception that little girls don't know that they are not supposed to like computers. When my Al Gore foray and adventure continued, no one made the connection for me that okay, this whole fan site making exploration is one thing, but in addition, you're actually, I was a little girl who liked knitting socks, and I was a little girl who liked philosophy and Bernard Russell especially, and I liked conjugating French irregular verbs, very sort of nerdy stuff, but not mathematical, not introverted, not sort of the traditional coder guy. But no one made me the connection that, hey, actually, when you're conjugating French verbs, you're recognizing patterns. And when you're knitting a sock, you're following a sequence of symbolic commands that have loops inside of them. Repeat this line until you hit your elbow, and so forth and so forth. And that actually Bernard Russell, whose life quest was to find an exact language between the spoken language and the mathematics, his work found itself in the side of the computer. And I felt that the world of technology and computers were foreign and not welcoming to me, but the little girls of today, they don't know that they are not supposed to like computers. And the thing that we adults need to do is create a curriculum for them where they feel empowered, where they feel that, oh wow, I'm actually really perceptive. I don't give up easily, I can concentrate for a long time, and I'm really creative. I can be an amazing programmer. And that's what I set out to do. So I listed all of the things that I felt were foundational skills behind even learning about programming, before even learning about like actual programming skills. So stuff like algorithms, really hard and big word, but actually any one of you who has ever made a cupcake recipe has in fact made an algorithm. A good cupcake recipe is something where you can swap blueberries to bananas and make different kinds of cupcakes with it, or swap the amounts of cupcake ingredients and make more and more cupcakes. You're following step-by-step instructions to solve a problem. That's an algorithm. Or if you talk about repetition, loops, computers are really good, actually like the best working friend a person can have. Computers are really good at repeating boring stuff. They don't need lunch breaks, they don't get sick, they don't mind repeating things over and over again, but you need to be able to construct that loop. And this is how little Ruby does it. She has a favorite dance party move. Her favorite dance thing is clap, clap, woo. Clap, clap, stomp, stomp, clap, clap, and jump. And with kids, I would do this exercise where we do a for loop. First, we repeat this sequence 3 times. We do a while loop, so we repeat this sequence while I'm like standing on one leg and holding my nose. And we repeat this sequence until mom gets mad, and so forth and so forth. And they learn about the basic foundation of a loop. And finally, the idea of decomposing a problem. We use flowcharts. Each of Ruby's friends on the right-hand side has a problem. It seems like Android has overflown the bath tube, and the fox has taken steps in the wrong order, and there's little Ruby who seems to have an infinite, or the wrong way of going loop inside of there. And kids learn to take problems and decompose them into smaller problems. And I think this is at the core of creating this new kind of curriculum, the 2 joys of programming. There is definitely the more intellectual pleasure of writing a beautiful algorithm, of writing a program that calculates the square roots of the 21st prime numbers. But that wasn't for me. My joy in programming came from hacking the computer and figuring out stuff and copy-pasting, and whoa, oh boy, I made this happen. I made the computer obey myself. And I feel like that's called play, and that was what I was after. Luckily, there was a lot of people, especially in the media industry, who know about play and who recognize that it's really, really important for our cognitive, social, emotional, and biological growth. And Sesame Street, John Kanscuni, who's the founder of Sesame Street, said that what if we can teach all of these boring life lesson things for kids through fun? And Sesame Street has been doing it for 34 years. And there's one company even closer to us called Lego, who's a really stellar example of play. And they distinct play in these 5 different categories. And for some reason, when programmers talk about play, they only talk about games with rules, even though we have this whole world of other type of play. Here's another chart from Lego. They list out the different motivations of play. So there's achievement-based motivation, there's social motivation, and there's immersion-based motivation. But for some reason, when we're teaching stuff, not only programming, teaching anything, and we talk about gamification, this is the only chart we use. We talk about progress and power and optimization and challenging others and domination and provocation. In reality, anyone here in this room who has ever programmed knows that there's a lot of like self-disclosure, finding and giving support, exploration, finding hidden things, and at least for me, avoiding real-life problems a lot of the times. And I decided that, okay, the curriculum of code is what I want to teach. Here is how I want to teach it, like using all of the aspects of play. And I wanted to come up with a few different rules of how to drive my product development process, because again, I had 10,000 people waiting for me to ship this book, and I had no idea what to do at that point. So I came up with 3 principles called playfulness, curiosity, and rules. And I'm going to go really quickly through each one of them. All of the exercises I'm mentioning over here can be found online. So this evening you can go and print out the computer exercise I'm going to show and do it with your kid and find them online and see what other kids have done. This is a Danish girl who has password protected her door with a computer. Kids nowadays, pretty special. So, up to the principles. First principle, principle of playfulness. Asking the question, what if, and making something ordinary into extraordinary. So you already met a little bit of Ruby, but let me introduce you to her properly. She's 6 years old, completely fearless and a little bit bossy at times. So when her father comes to her and says, Ruby, we're running late from school, dress up really quickly, she will put on her little dress, but she will leave her pajamas on because Dad didn't specifically tell her that you need to take your pajamas off. And when Ruby is asked to clean her room, Ruby, your room is horrible, you have toys all over the place, she will clean her toys, but she will leave the pens and papers on the floor because Dad, pens and papers are not really toys. And there's a chance that I'm teaching or educating the most obnoxious generation of kids there is, but they learn also something very profound about how you give instructions to a computer. You need to be very exact, give the orders in the right sequence, and be very careful when naming things. And this is the perception of programming, that it's only a sequence of ones and zeros. When a programmer codes, they have this weird mathematical thing going on in their heads and they write ones and zeros, ones and zeros. No, programming is about taking a big problem and decomposing it into smaller problems. And a programmer doesn't write ones and zeros. The computer reads ones and zeros. The programmer writes a language that is meant for other humans to understand. And the cool news is that programming has gotten a lot easier in the past 20 years. On the right-hand side, I think that's assembly code or COBOL, I don't remember even anymore. Both of the codes produce the same thing, hello world. On the left-hand side, that's Ruby code, and it looks like modern English. And as I said, when I talk with little boys and girls what they want to do when they grow up, there's so many little kids who want to be game designers, of course, and game developers. And I tell them that the first step to become a game developer is to actually decompose your favorite game, figure out who's the hero, what's the goal, where's the time, who are the villains. And these are the brains that a programmer uses every single day. And the most important thing you need to learn in life is actually that oftentimes even the biggest, scariest, hairiest problems are just small problems stuck together. So the second principle is the principle of curiosity, asking the question, why? Why? Exploring and finding hidden things and imagining stuff. And one of the biggest pet peeves I have is how technology is made into a black box for us. When our kids come to us and ask, hey, like, is internet a place? Or, Linda, what actually happens when I press the play button on YouTube? Or Linda, what is a bubble sorting algorithm? I'm silent. I mutter something about, oh, it's like magic, or it's very complicated. Well, it's not complicated, it's not magic, it just happened really, really, really fast. Computer scientists, they built layers of abstraction on top of each other to the point where we have our fancy iPhones, like faster computers than the one humankind went to the moon with in the 70s, but we have absolutely no understanding how it works. And technology is supposed to be tinkered with. You're supposed to open up your phone or your computer or whatnot and wonder how to make it better. And one exercise I do with the kids is one where I give them these little on-off stickers with an on-off button on them, and I tell them, just this afternoon, just today, you have this magic ability to make anything in this room into a computer by putting your little sticker on it. And the kids start by saying, oh, that's really hard, and I don't know the right answer, and oh, I don't know what to do. And I tell them that, you know what, your parents don't know the answer either. They talk about something like Internet of Things is a thing that is happening, but you guys are going to be the ones who are going to grow up in a world where every single thing is going to be a computer, and it's really up to you to start figuring out that world and taking responsibility. And I had this little boy who was really uncertain about this exercise, and he went and snatched this bike pedaling lamp, and I asked him, okay, so what does your computer do? And he's like, maybe when I press the button, the like lamp color changes into something else. I'm like, super good idea. What happens next? And then he thinks and thinks again, and then I see the biggest smirk and smile on his face, and he says, okay, when we go on a bike trip with my father, and then we spend the night in the tent, this like bike lamp could also be a projector, and we could watch movies together. And he has this biggest, smuggest smile on his face because he's learned something very profound, that the world is not ready, And that one really awesome way of making the world a better place is through technology. And there's a chance that he will never do this bike projector life thing, but for a moment there, he saw that that is a possibility, and that it could be his thing that he starts to do. The third principle, and the final principle, is the principle of rules. Asking always the question how, and imposing a logic on something otherwise hard to understand. What really bothers me is that actually we've made this whole machine-like world where we feel like computers are cold and analytical and machine-like, and in reality the computer is the grandkid of mathematics and poetry. Because the first programmer in the world was Lady Ada Lovelace, who was the daughter of the philandering Lord Byron, the poet in the Victorian England, and a mathematician mom. And the parents never lived together, really. And the mom said that my daughter is never going to do anything having to do with poetry. And Ada was brought up as a mathematician, and she had this huge yearning to learn about the analytical engine. And she found Charles Babbage in the Victorian era London, and everyone was gushing about this thing called the computer, but at the time, computer really meant a calculator. Something that calculates numbers. At those times, you would have books and books of just numbers, like squares and roots and so forth, because it was mechanical work and not everyone could do it, and you needed those things. And everyone else saw the computer as a calculator. But Ada made the distinction that hey, actually numbers can represent logic, and logic can represent anything. And that's the moment when the modern programming world was born. And somehow we've forgotten all about this. And when I work with kids and I show them a few pictures of what is a computer, like is a car a computer, is a grocery store a computer, is a toilet a computer, or is a dog a computer, they all very solemnly say to me, none of these things is a computer. Are you silly? The computer is the thing that mom or dad spends way too much time in front of. And we tend to think that kids are creative, but actually they are really traditional. They reflect a lot of the ideas that their parents have about life and the experiences they have. But then we get to talk, and we learn that, actually a car can really be a computer, because a car has a navigation system, and there's all sorts of computers inside of the brakes and so forth and so forth. And a dog might not be a computer, but a dog's collar band might have a little microchip inside of it, so you can see if your dog runs away where it goes. And actually, grocery stores have all sorts of little computers inside of them. There's the machine that keeps the ice cream cold, and there's the teller, and you know what, when your parents were your age, computers were so big that they couldn't fit on this stage. And when you're going to grow up, computers are going to be so tiny that you can fit one each side of each milk bottle. And that in Japan, toilets already are computers, and there's like a whole generation of hackers who are like specialized in hacking computers, and this always cracks the six-year-old ones up completely. And that each and every one of you has hundreds of computers inside of your home, and learning to think in a way a programmer thinks about, learning to instruct your home equipment, like when you turn, if the button is pressed, then a bell, ring a bell for 10 seconds. That's already programming, being able to very expressively say something. One of the things, a computer, like the concept of a computer, is still so much driven to the physical, tangible box to us, that one of the things that I try to do with kids is just let them go of that. And we talk that a computer is actually anything that takes in data, does something to it, and out comes something else. And the beauty of a computer compared to a tractor or a game machine is that it has two types of memory. There's the memory that stores the data that comes in and stores the data that goes out, but there's the memory that gives the instructions to what to do to the computer. And that means a computer can be anything depending on what kind of instructions you give to it. Absolutely anything. A tractor can only be a tractor, and a pinball machine can only be a pinball machine, but a computer can be anything based on the instructions you give to it. And just to make it a little bit more fun for the kids, we also do the same exercise as a cardboard computer box, where you have little code instructions inside. For instance, come out wiggling yourself, or jump on one feet, and then the kid goes inside, reads the code, and comes out as the input code, output, and then the other kids need to decode what happened inside of the computer. And this is like 3-year-olds love this exercise a lot. One of the other things the kids do is they build their own first computer, and they get to know the bossy CPU, the helpful RAM and ROM that help it remember things. They get to know the hard drive that stores your game levels and your summer photos, and they get to see what happens when you put a virus inside of the machine. And it's really funny to see how well kids understand and react to these things. It's us adults that really have the perception that this stuff is complicated and hard. The basic building block of a computer is a switch that goes on and off. And it's just layers of abstraction built on top of it. And when I was researching this project and trying to teach kids how a computer works, the only thing that I would run into were these mindless, like Microsoft advertorials saying that this is the term, this is the screen, and this is the keyboard, and this is the mouse, and here's the printer. And I'm like, kids know this stuff already. They don't need to be taught this. But when I would search further, I would run into Minecraft and these crazy forums where kids would take these computer science research students' work and start building actual working virtual computers inside of Minecraft. You see, Minecraft has conductive redstone and non-conductive stone, and that means you can build a working computer from the tiniest ALUs and the CPUs and bits and bytes, and just build layers of abstraction on top of each other until you actually have a working computer inside of your computer. And I was baffled. Most of the stuff went way over my head. But the kids didn't know that it was supposed to be hard and that it was supposed to be done by computer scientists only. And they just kept happily building these massive cathedrals or palaces of their computers that you could walk inside of and see the tiniest logic gates in action. The kids also get to design the buttons for the computer, and I had this little friend called Arthur, who's 6 years old, and Arthur loves Lego. The favorite thing in his life is Legos, and he had coloring pages printed out by his mom by the lego.com website. And the first button he very proudly designed was a button to print out Lego coloring pages, but pretty soon he was bummed, like, the coloring pages are stupid. I'm going to design a button that allows me to print out Legos. And then he went completely wild and started printing out CDs and toothbrushes, and then breakfast for the entire family. And the next morning, and Arthur's mom, who's a really close friend of mine and usually really good with these things, said, "Arthur, that's not possible." But the trick is that it's going to be possible. Arthur is going to grow up into a world where he is going to 3D print his Lego blocks. He is going to 3D print his Saturday morning candy. And it's just a good thing that he sees it as a world that he belongs to. My absolutely favorite stories come still from two little kids who designed their first web applications. The first one of them is called Ada. She's 6 years old, and her favorite thing in the world she wants to become when she grows up is to be a dolphin doctor. And Ada's pretty determined that dolphin doctors don't need computers. This computer business, not that sure about it, but we get to business, and she designs this amazing dolphin health application with the little patient pictures and like a dashboard and analytics of the health stats. And boy, do I want Ada to be the one designing the Finnish health digitalization reform, because she had an intuitive knack into what the patients wanted to do and no fear whatsoever in doing this. And the other story is of a little boy whose favorite play in the world was to be an astronaut. Or more precisely, he was the mission control man. He has these huge headphones on, and he's absolutely totally immersed in his paper computer. He's built his own intergalactic planetary navigation application. And the boy's father, the lone astronaut on the other side of the room in the Martian atmosphere, far, far away, his sole responsibility is to bring father safely back home. And this is a generation of kids that is going to have a profoundly different experience in how, when, where, and why we should be using technology to change our world. My ending is probably this. I think every problem will be a computer problem. Usually, it's easy to say that a physicist studies the physical world and the biologist studies the biological world. And when I ask people, so what does the computer scientist do? They say, do they study the computer? And no, a computer scientist, a programmer, or anyone with the ability to speak the language of the 21st century, they solve real problems using a computer, and that's a huge distinction. And all problems will be computer problems, because if you're a biologist, you'll need computers to sequence the DNA. If you're a doctor, you can use computers to help you diagnose your patients. If you're a teacher, you definitely have a huge responsibility towards the kids to help them see the power of computers. It doesn't mean that every kid needs to become a coder, but it means that it's our responsibility as adults to give the experience of technology for kids. None of the stuff that I talked about was really new. There's been a wealth of research into this stuff. There's Alan Turing already in the 50s. He talked about artificial intelligence and how instead of trying to crack the system, we should be thinking of computers as little kids who learn to learn. And there's Seymour Papert and Cynthia Solomon who did this amazing foundational work on 20 things to do with computer and said that, oh, you shouldn't be calculating the square roots of 21st prime numbers. You should be doing something practical and visible and joyful and delightful for the kids. And if you haven't read the Alan Kay story, he was one of the Xerox PARC people who Steve Jobs stole all of his stuff from. In the 70s already, he's imagined a complete hackable iPad for the kids. It has a picture that is really eerily reminiscent of today. And stories and the software world, they go back. I'll be signing my books out there, but if you're interested in this stuff, there's a ton of really cool books out there. There's Ruby Wizard, there's Computational Fairy Tales, there's Lorem Ipsum, there's my personal favorite called Wise Boy Poignant Guide to Ruby that got me involved in Ruby again. And I think we need these bridge makers, the people who can tell the stories of software to the people who originally feel that they don't belong to this world. But in reality, technology is humanity. An internet was built on humanity, and a computer in the Victorian era was actually a person who calculated things. And the technology, the very word, originally meant not only the technique, not only the tools to get a job done, but also the techniques, skills, and competencies to do it. Oftentimes, I get questions that ask, what is it with you Scandinavian people and your red-haired little heroines like Pippi Longstocking and Little Moo and so forth and so forth? And I usually answer the same thing. I think we all have childhood stories that have really shaped the way we grew up. Those stories that stuck with us and refined to us what it is like to be a member of the society, what it is like to be a husband or a wife, what it is like to be a child. And those stories stay with us, and that's why it's important to tell this story. Thank you.
Kiitos, Linda. Aivan ihanaa.
Oh, wow.
You should stay on the stage just for 1 second
yes.
before we wrap up. Because I saw this wonderful tweet by Livia, who spoke earlier today, and she said, oh, I love Linda Liukas' second principle about curiosity. Why do we forget about this as grown-ups? Why do we? Because I think, this book is not just for kids, it's for everyone, right?
Yeah. It's funny, so this wraps back to the Roy picture in the beginning. I feel like I'm in such a privileged position that I get to play test with kids every single week, and they keep reminding me that, oh wow, the world is actually infinite and full of possibility, and maybe my job is then to remind all of the adults here. And I definitely agree with you. I started this project as an education project for kids. Now I'm slowly starting to realize that I'm actually educating the parents as well.
Right, exactly. Thank you for doing that. I hope you all feel encouraged.